and welcome to AWS Made Easy, episode number 13. I'm your host, Stephen Barr, and our co-host, Rahul Subramaniam. How are you doing,
everyone?
Rahul?
Great. I can't believe we are at 13 episodes now. Every single time we do another episode, I feel grateful that we're able to do this every week. So great going. I can't wait to get to episode number 20.
Absolutely.
How was your
I'm
weekend?
looking for adding another digit, 100. Oh, weekend was really, really good. Pretty relaxing. It's been really hot this week, so lots of swimming and that sort of thing. I mean, not hot by your standards, but hot by ours.
Yeah, it's all relative. Over here, I think given the way the pandemic has been, we suddenly find ourselves, as schools have opened up, managing our kids' hectic social lives. This weekend, we had 3 different birthday parties to go to for our kids. So chaperoning them from one part of the city to another was how we spent the entire weekend. And the other exciting thing is I am helping run a new robotics program at my kids' school. So that's been really exciting. So lots of new things that we are trying to create, some exciting projects around. So yeah, we'll have updates over the next few weeks on how that is going as well.
That's exciting. Are you using Mindstorms or custom build or Raspberry Pi or Arduino or what platform are you
So
using?
we are starting with the Arduinos, but then moving on to the ESP8266s. So they have some Wi-Fi. The end goal is that for the school, they'll build these little boxes which have all the sensors, from temperature sensors to humidity sensors to NFC, sensors that will allow students to have their cards and come in and do an auto attendance. Then tap into the cameras that are in the classroom to be able to, figure out how students are engaging and who's present, not present, and so on. So yeah, lots of really interesting things in the works. We just have to see how this pans out. This is for middle school, by the way, grade 6, 7, and 8. So yeah, quite interesting. Going back to teaching after almost 20 years. So should be fun.
That's really, I'm really excited to hear how it turns out and to hear how it's received and how the kids progress through that. So yeah, let's revisit that at some future point.
Absolutely.
Well, today we have a really special guest. I'd like to give a little introduction, even though it doesn't really need much of one. Today, it's my pleasure to introduce Jeff Barr. Jeff is the AWS Chief Evangelist and VP. So he's been at Amazon for more than 20 years. And he started working with them when they were mostly a company working out of the old PacMed building. And he's been a web services evangelist since 2003. And in that time, he's basically defined the phrase technical evangelist. And on a personal note, I'm proud to say he's my dad. So without further ado, let's bring in Jeff.
All right.
Welcome to the show.
Happy to be here. This is fun. I love that printing effect. That was really cool.
Oh, cool. I'm really glad.
I think that's one of the 3 or 4 things that we all share in common in this group. There's 3D printing. There's, of course, Lego. And I'm surprised you don't have your Lego background, Jeff.
I'm doing virtual right now. I've got a green screen. So I'm doing green screen today so I can do some good effects a little bit later.
So you're really excited to have you with us today. And we're going to have hopefully a very engaging discussion. We have so many questions for you, so can't wait to get started.
All right. I hope I have just as many answers as questions.
It's funny, kind of going over your introductory post and kind of preparing the introduction. I was oops, let me share the right screen. This is my memory of you taking me to your office when not even that whole building, but the top 2/3 was Amazon.
Yeah.
And all of Amazon.
Yeah, those were really old days. That's a very good picture of that building because they started to be a little bit more particular about pictures after a while. But that brings back some really good memories of being on the different floors of that building. And I started low and actually just somehow worked my way up to upper floors, and like that upper spire, there must have been room for like less than 20 people in some of those uppermost floors.
Oh, wow.
It was a pretty cool classic Art Deco architecture, and it was pretty inspiring for me to see that as a teenager when you were just starting there.
Origins.
Well,
you never know when you start something where it's going to lead you.
Well,
Very,
I
very
think
true.
we're going to make a giant leap then, and talk about one of your most recent blog posts, the AWS snow cone in space.
Mhm.
So we'll introduce that segment, and then let's have a good chat about that. All right.
All right. I do want to go into space. So
Yeah. So this actually was really, really exciting to hear that, you guys sent a snow cone to space. We'd love to hear the backstory. Like, what went into the exercise? Number one, how did it all start? Like, like sending something to space isn't the first thing that comes to mind when you have a service or you have an edge use case. How did it all come to being?
One of the interesting challenges of being in space is that the bandwidth up and down is actually very, very limited. And there was a question about they wanted to do some image processing as close to the images as possible. And they said, okay, we've got all these pictures. We need to identify certain things in the pictures. We don't think we actually have the ability to bring the high-res pictures down to Earth and do the image processing and recognition and so forth on Earth because of this limited bandwidth. And because we've been focusing on edge computing for a while and getting the processing out closer to where the action is, the snow cone seemed like an ideal solution. And there's an entire qualification process you need to work through of, okay, here's a device. Can it withstand the rigors of launch? Will it work properly in microgravity? Is it safe? Is it going to keep the ISS safe? Is it going to keep the astronauts safe? So quite an interesting process.
Well, we saw. Go ahead.
I was just going to ask, how long before the launch did that process actually get started?
So my understanding is it was accelerated, that it was somewhere on the order of about 6 months, and that by the standards of space travel, that was considered very, very quick. And partly that was because we had some great partners working with Axiom and working with NASA, but then also because of the fact that when we build these devices, we make them incredibly rugged to start with. You can find several different videos online of people doing their absolute best to destroy the various snow devices. There's one that we actually sent one to Adam Savage and said, please have at it and destroy this, please. And he tried some different machinery and explosives, and it's like, nope, it's pretty tough.
I've watched a whole bunch of those videos. I remember of trying to destroy it, but it just doesn't. This is one of them.
This is the intro video you did with Bill Vass, and I liked his ending shot with the puppies. I think he had one near his water fountain, if I remember correct. Here we go. That was clever.
Yeah. So funny thing, I think this was back in 2015 or maybe early 2016. This was one of my first EBCs that I actually did at AWS. And this was when you guys didn't have the EBC center. So it was literally just walking into the AWS offices and meeting with the folks who were there. And I think we were supposed to meet with somebody, I forget who. And that person was not available or was trying to get from another building over to the building where we were. And so we were literally just walking around the corridor, trying to grab a coffee or whatever. And we run into Bill Vass. And so Bill invited us, and then we started chatting, and we were telling him about how hard it was for us to move a whole bunch of our data from an acquisition that was recent at that time. And Bill was like, hey, you know what? We have this new thing called a snowball. And, we'd love for you to try it. And I think we got one of the very first snowballs shipped to us as part of the, experimental, let's try and move, data centers into AWS very, very quickly. I think it took us like 3 attempts to get it done, debugging and figuring out the solution. But it was awesome. It was such a game changer, when you have data centers that have tons of, workloads that are running over there, to be able to just suck it all up, put it onto this, snowball machine and have it show up in your AWS account. That is absolutely remarkable.
It's worked out really well. And one thing that's really interesting to me is that this is an evolution of something that we had started quite a bit earlier in the history of AWS, where when customers needed to do data migration to the cloud, we said, literally send us your hard drives. And we had specs as to what kind of drives they could send and how they'd prepare the data. And there were some really interesting challenges with that, as you can imagine. And then evolving from that into an actual, like, we'll build a device, we'll send you a device that is really good at actually pulling it's got the right level of storage, it's rugged, it's got the right level of connectivity so that it doesn't take you actually months or years to get all the data onto it.
Yep. No, absolutely. These are absolutely fantastic machines on the edge. So, just moving on to the next question. How are people using these devices on the edge other than backing up stuff and moving them to AWS?
So the newest Snowball Edge devices, they have a substantial amount of compute power on board. So the Snowball Edges, you can get them with GPUs, so you can do various kinds of image processing, you can do machine learning inferencing. And so what I like to think of them in general, beyond the kind of the mainstream use case of let's get data from somewhere out there into AWS. The other one is basically almost like a filtering system that says we've got this massive amount of raw data we are collecting at the edge, but we don't necessarily need all of it. And so we either need to pick the small set of that we would like to take, or we need to sum it up, aggregate it, pre-process it in some way, and then pass it up to the cloud. So I kind of think of it as this the filtering, aggregation, gathering, buffering device.
Got it. Any other interesting stories around any of these devices?
So I've had several of them in my house for various photo shoots, and they are somewhat unique looking. And I actually did have I had a Snowball Edge, which is a pretty heavy device. And I took one and I needed to return it to Amazon after I'd done my photo shoot. I actually took a picture of my dog Luna with it. She was very happy to be in the photo. And I carried it down the hill to the local UPS store. And I was expecting the guy behind the counter, I was expecting to have to explain what this was and why it was safe to ship and everything. And he's like, "Oh my gosh, another one of these cool things." So it wasn't as amazing or unique as I was expecting, which is like, I'm thinking, here I am in this residential neighborhood. Like, which ones of my neighbors are doing this massive amount of data transport to the cloud? It's a little bit interesting to think that kind of activity is somehow taking place within a little radius of my neighborhood.
With the assumption that there aren't any data centers around there, it sounds scary that people are running those kind of workloads from their homes.
you really just never know anymore. I mean, here we are. I mean, I'm in the lowest level of the house, and Steven's upstairs, and we're running 2 concurrent video streams out of our house, which is like apparently no big deal these days. So
true, very true. Okay.
Here's a question. How do you model the trade-off then between moving the edge and then investing in the infrastructure to get to the cloud? So what you can either say, okay, I'm going to get one of these devices and put it here, or I can invest in more bandwidth where I need it. So how do people think about that trade-off?
So what I hear from our customers is There are times when they're in the process of shutting down a data center as part of their cloud migration. And sometimes it's the case that they've let this data center get somewhat out of date, and that when they start doing the math and say, well, if we were to bring up the connectivity of the data center to the point where we could actually push all this data through the connection, and they do they think, okay, how much is that going to cost? How long will it take to do this? Versus the fact that we're trying to be done with this data center versus trying to invest more in it. I've heard of situations where they do the math and they say it's on the order of years to get all of this data out of our data center, because they've got poor connectivity, or they've got just colossal amounts of data, or sometimes the internal aggregate network bandwidth in these data centers isn't wonderful. And they say, well, we've never actually had this case before of needing to get to all the data, and like we're not going to rebuild the data center just so we can shut it down.
I was watching the Snowmobile talk, and they said that at 10 gigabytes per second or 10 gigabits per second, it would take 26 years to fill up a snowmobile. So being able to, they're not going to be able to do that in any kind of reasonable time frame that would matter.
Yeah, so orders of magnitude can multiply out really quickly into like that's actually impossible.
True. I think for us historically, I mean, since we started using snowballs, we've never had a chance to use a snowmobile yet. I don't think we've ever moved that kind of data, but snowballs for sure. I think for us, it was always the trade-off when it came, or whenever network bandwidth or latency started becoming the bottleneck. I remember a time when just getting a direct connect link set up would take a minimum of 60 days. Just working through the vendors, making sure that all those connections, could be set up in whatever data center you were in. Like in the early days of direct connect, I think it would take almost 90 days. And then slowly it came down to 60. Then we were attempting to get to 45 days. But, it would take a minimum of that much time just to get a connection set up with enough bandwidth to start moving the data, let alone, get the migrations done. And we were trying to get most of our migrations done in a period of 90 days. So
yeah, all of those physical activities involved in getting that connections, and all the dealing with telecoms that are certainly trying to be innovative and to move quickly, but there's still just a lot of process and a lot of steps in those pipelines to make something happen. So
correct.
Send us the hardware, we'll copy it in, copy it out. Just seems to work a whole lot better.
Absolutely. So there was that, and then there was the other latency aspect of it, which is, sometimes just things are so far away that just speed of light latency becomes a bit of an issue, and you want stuff on the edge.
Yeah, there are protocols that are supposed to address that keep a lot more data flowing across the pipe, so you don't have to have individual acknowledgements for each packet, but still getting those things set up and getting them to run at scale, you might need a lot of compute power to actually keep the connection busy. And it's specialized expertise that, like, why bother to develop that specialized expertise in a situation where you're saying we're now moving in the direction of not needing that expertise and that equipment? Why invest when you can just use the hardware that we can provide you?
It's not core business anyway, and it's never going to be. So why invest in it?
Exactly.
Speaking of hardware, are there going to be at some point a Snow device that has a Graviton inside of it, or is that already the case, or do we know?
I actually never. Believe it or not, I know very little about where we're going with these, and the process when we are getting ready to launch something new is that generally about a month ahead of time, the teams will create an internal ticket. They'll attach the Amazon document called the PR FAQ. That's the press release and the frequently asked questions. They'll give us a quick briefing. They'll give us product access. But even though we have the teams generally have at least a year to 18 months of a very concrete roadmap of what they're doing, I do my best not to look at it, mostly because it keeps separate. It helps to separate in my head what's real versus what we're working on. And they also reprioritize a lot. So when a team launches the first iteration of some brand new big service, they will often have a very long roadmap of these are things that we want to do. But as soon as they launch, the immediate customer feedback that comes back will start to point them in other directions. So you'll see that some companies will say, okay, here we are, and it's 2022, and here's where we're doing 23, 24, 25, and so forth. We have some good ideas of generally where we'd like to go, but we'd much rather hear where our customers need to go and just let that drive our roadmap. So the short answer is I have no idea what we're building next, but we'll keep trying to fulfill customer use cases.
But safe to say that none of these devices currently have Graviton processors built into them?
Not as far as I know.
Okay. Got it.
All right. Well, do you at least know the name of the next one?
I don't.
I could suggest either snowplow or snowshoe.
Okay.
All right.
I heard someone once asking for something like the size of an aircraft carrier for like those truly like earth-shattering levels of data migration, but
who has
that's
those
an awful
needs?
lot of storage.
I wonder whoever has those kind of needs.
Yeah.
Well, let's see. Anything else on the space front before we move on from the topic? Like, what was
Well,
it like?
I found space really exciting because like I've been a space fan since I was like maybe 5 or 6 years old, and I remember learning about like the Mercury and the Gemini, and then the Apollo launches and following those, and we just passed the anniversary of the first moon landing, and to be this close to doing that, and to be able to just even to read about it and know that my colleagues are getting to participate in this, it's really, really fascinating. And to me, the more interesting thing, and talking to a lot of my colleagues that are doing this, the connection between science and science fiction, there's actually this really cool circularity where science fiction provides this amazing vision of where the future could go. And then people are inspired by that and say, well, if someone can dream that up, then we can probably actually invent this. And it's a much more circular relationship than an outsider might guess. Like how important the speculation and the science fiction that's often informed by possibilities and by science and by physics to say this is where we could go. And someone's like, oh, well, if we could go there, well, let's try to do that.
Well, I guess one of my favorite physical books is your old copy of 2001: A Space Odyssey with your 10-year-old handwriting in the cover. And I'm looking forward to reading to my kids.
Awesome.
There's actually a very interesting documentary that I saw a few years ago. It's called How Star Trek Changed the World. I think it's hosted by William Shatner. And it talks about how everything from the mobile phone to the sliding doors were created by people who got really inspired by what Star Trek had shown and went ahead and built those things. Like the flip phone and all of those things kind of came from, the communicator in Star Trek was the inspiration for the flip phone.
Yeah.
So it's pretty amazing how much science fiction kind of inspires us to go do stuff.
Totally agree.
All right, well, let's end the segment, and I'm going to end the segment with a little montage I put together of the AX1 to
2, 1, 0. Ignition. CM1
has like deploy. SpaceX Dragon launch.
0 G. If you look at the right-hand side,
He's 2 meters.
1 meter to go.
Contact.
So Tom Marshburn making his way down.
pretty exciting that there was a snow cone back in the storage compartment there.
I'm jealous of all those astronauts.
Well,
yeah,
who knows? Maybe you'll get to take a ride in one of the later iterations.
Do you get a discount program on the Blue Origin flights that are coming up?
Not that anyone's told me about yet. I volunteered to go along as a blogger, but so far no response.
There should be some perks of being, one of the early ones at Amazon.
I would hope. I want to feel those G-forces. That I would love that just crushing G-force. I have to imagine that's just a feeling that's pretty hard to replicate anywhere else.
Yeah, I can quite imagine. Okay.
Well, let's take a 30-second break, and we come back. We're going to be talking about Prime Day.
Well,
public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, so tell us about Prime Day.
Wow, Prime Day is always exciting, and from the what I love about it is behind the scenes, the teams that keep all the Amazon infrastructure running, they spend months getting ready for this to make sure that all the different pieces of infrastructure are going to perform flawlessly. And I remember in the earliest times at Amazon, scaling. This is before AWS, and this is one of the motivators for AWS is that there was an actual spreadsheet that was passed around from team to team that you would basically say, here's your team, here's the servers that you have, how many do you need for the next holiday scaling season, and when do you need them? And each team would fill that in and pass it along, and there'd be some negotiation of timing and of exact allocation. And that was such an obstacle to scaling, and it was a big, complicated thing that you have to do every year. And of course, it's really hard to plan how much resources you need. And if you're innovating and you've got some new services, you never know how popular that part of your site's going to be and how much you need in the way of resources. So getting to this point where it's AWS powered and there's great things like auto scaling and serverless, it doesn't make it like effortless, but it means that it's a different kind of effort where a lot of the work that goes into it is more in the way of projecting and planning and making sure that each part works well and making sure that you understand the scaling characteristics. And so that when it happens, it's a matter of just watching the metrics, making sure that everything's heading in the right direction. If you see something not in the right direction, like what can I adjust before it goes from it's purely noticed internally to something that customers will notice. So it seems like every year we get better and better at this.
Yeah, the numbers are actually absolutely staggering, and every year you guys beat them by quite a margin. And what I find baffling, in fact, I struggle with it even internally, is just being able to predict the demand, both on the minimum requirement side and setting a cap, because you kind of don't want, like, there's a fine line between letting something, run away because there's some error somewhere, and you've suddenly got 100 or 1,000 instances of something running, and suddenly a bill is kind of super bloated. Versus actually looking at something that is pure demand and reacting to it responsibly in an elastic manner. How do the teams go about doing that? Is there any light you can shed on that exercise that happens at Amazon on being able to do that estimation?
Yeah, so one thing that I know that the teams like to do is that they generally like to establish expected ranges for a lot of the metrics and say, well, in general, we know that this particular metric will be between low bounds and high bounds, and they'll set alarms on either end. And one of the things that I know that we used to talk a lot, I don't know if this is still the case, I'm guessing it still is that in a distributed system, it generally doesn't fail all at once. It will tend to start slowing down, and instead of 100% of the things working, 99.99% work, and then 99.98 and so forth. And if you can detect those tiny like failures and retries and the situations where maybe a queue is getting slightly longer or a buffer is getting full, those are things that you can alert on very early and take protective action or preventive action before it becomes customer visible. And the ultimate metric that we watch on the retail side is the number of checkouts per second. So that's an awesome metric because that means everything else has to work. The website has to be functional. It has to be able to display content to the users. It has to be able to accept things being put into the shopping cart. The checkout process has to work. Probably 1,000 other things I have no idea actually have to be there. But to the point where you've actually successfully done a checkout and your order is now in the system and we're getting ready to do the fulfillment. So many pieces have to work that watching that number turns out to be a great early indicator of something else might not be right. Now, we have a couple of, I think, almost unique advantages that help us. We've been doing this for a really, really long time. So we have expected values on upsides and downsides of where these metrics should be. So it's very easy to say, well, where was this yesterday at this time? Or during the last Prime Day peak, where are we comparatively? I think that having that long history is really helpful. What was my second point? The second one I think is more important. We're running at such a scale that the numbers really make a difference. I think this is a challenge if you're not at world scale and your numbers are not millions, billions, trillions. We even have things I think we measure in quadrillions sometimes. When things are that big, the math works out and trends become really visible. If you're dealing with ones and tens and hundreds, you probably have to have a slightly different approach because the statistics aren't as accurate or as helpful to you.
True.
Well, looking at your blog post, looking at the SQS, so this is 70 million transactions on SQS per second. SES was 33,000 emails per second. Let's see, 152 petabytes to EBS. It's some huge numbers. 5,300 Aurora database instances for 288 billion transactions. So yeah, by the law of large numbers, you will see every statistical phenomena that's remotely present in the data will appear.
Exactly.
How do the teams organize themselves to tackle? I mean, the Amazon system is presumably a very, very complex system with, just given the number of databases and stuff that are being used, the number of queues that are probably getting used over here. This is a very, very vast and complex system. One of the challenges of a complex system like that is that you're likely to get overwhelmed by the number of metrics that you're looking at the lower level. It's great to have that one metric that gives you an early indicator, like you said, number of checkouts. But when you get into the next level, when something does go wrong, there is a very high likelihood that you could get overwhelmed with just the number of alerts and alarms going off all over the place with that many services that are interlinked or which have a strong cohesion of sorts, trying to get everything working. So how do the teams organize themselves in terms of tackling a problem when there is a problem?
So my understanding, and I haven't been operational for a really long time, but each team owns a particular service, and we always call them a 2-pizza team because we try to keep them small enough that 2 pizzas of some arbitrary size with arbitrarily hungry staff on there would be happy with. But the idea is that each of these small teams owns some very particular important microservice, essentially, that helps the site to succeed. And so it's up to that team to figure out what that service should be, build it, figure out what metrics to watch and to track and to alarm on all those metrics, and to make sure that they know who their customers are and who their dependencies are, that all the customers that are counting on them. So instead of one, like, you used to see these pictures of these like ISPs and telecoms with these gigantic rooms and big screens and the central operations center.
Yeah.
I don't think we have one of those because that kind of assumes this central level of control versus we're saying if each of these individual teams does their part, then we're much more closer to success than having some central team that somehow has to monitor everything. Now, clearly there are situations when something does go wrong and multiple teams are involved. And when that happens, a ticket is cut. Usually it's actually an automatically cut ticket because some metric went outside the bounds, and it says, well, this metric went too high, too low for 5 successive checks. Let's cut a ticket. And then the idea is each of the teams that might have some involvement in there, they have to actually log into a shared phone call. And from there, they start very methodically working through and saying, does it look like this? Does it look like that? And again, because it's a distributed system, it's sometimes in the connection between the systems rather than is any particular thing failing? Well, not one thing is failing, but when you connect these two things together, they're operating in this interesting way that we've done our best to predict and forecast, but sometimes there's still surprising dynamic behavior. But things that you keep identifying and getting better and better at over time to understand.
That sounds pretty interesting, but at the same time scary to have that distributed a setup and still have everything work. It's got to be a really well-oiled machine.
It's well-oiled. One thing that I think is in our favor is that we try really hard to learn from every event. And there's this Amazon, not tradition, it's deeper than a tradition. It's a best practice and required, is that anytime something goes wrong, the first thing we do, of course, is get things back on track and restore service for our customers. But then someone is appointed the owner of a document called a COE, a correction of errors. And the idea is that you go back into all of the log files and you say, okay, what went wrong? And sometimes you put together almost a millisecond by millisecond recounting of this happened and then this happened and then this queue got a little bit too high, and so we tried to scale, and then this other thing happened. And then you basically, without pointing any fingers at people, you're always pointing, you're saying, well, this system didn't work and this alarm didn't fire. You say, first, what went wrong? And what do we need to do to make sure that this particular thing can never, ever happen again? Sometimes that is involved with just simply adding more alarms. You'd say, well, this particular situation, we didn't even know that this was a thing to monitor, but let's make sure we monitor it the next time around, and we'll just add some more alarms and alerts. Or it might be, well, we discovered this new behavior, and we need to do some more engineering work to get around it. But at any point after one of these situations, remedying that technical issue, it becomes the highest priority for the team. So in any of we've had a few very high profile, but fortunately very rare visible events over the years. At the point when we figure out why did that happen, making sure it can't happen again becomes the very highest priority for the team, where they will say, we're going to push everything else on our roadmap. We'll just push that a bit into the future. We're going to make sure that first one, I'm not saying it's acceptable, but it happened. But doing it a second time, that's for sure not something we would allow. Now, the iteration of this process over years and years and years means that we keep building more resiliency into the system, which is super important. But the other cool thing is that these COEs are numbered. And when you start talking to our principal engineers, and a principal engineer is someone with decades of experience and is basically like the equivalent of a director or a VP, but they still get to build and architect systems. The more notorious and the COEs where you can learn the best lessons, they've got numbers that you listen to these principal engineers and they're like, oh, do you remember 253? Oh yeah, that wasn't as bad as 155. But yeah, but we learned a great lesson from 157, which we now tell everybody to use that. And it's fascinating to see how much we've learned over the years. And these are hard-won lessons that we don't forget, and that each one of these is going to help us to do something better and better over time.
That sounds like more than a best practice. It seems very ingrained in the Amazon culture.
It's fascinating to read them. Even my best days of actually building stuff with code are long, long, long past, but I can still read these things and understand them and say, we've got really sharp people building and running these. And another aspect of it is that once a team builds something, they also have to run it. We're not kind of like this old school model where there was this team of engineers who built things, and in the engineers' heads, everything was perfect. And then they'd hand it off to these poor folks over in operations who had to deal with whatever stuff was thrown their way and try to actually keep it running. And of course, there was plenty of finger pointing, and issues with operational issues didn't always get back to devs. So the way we like to run things is that the same people that built it, they're the ones who are actually going to be on call and to make sure that when something breaks, they're the ones that have to dive deep and figure out what went wrong. I still remember my first day at Amazon, and I had lunch with my manager, and he hands me a pager. I don't think we use pagers anymore, and probably the audience doesn't even know what pagers are.
Yeah.
He hands me a pager and says, "You are the secondary on call in 2 weeks." And the implication of that is, oh my gosh, I'm going to be responsible for keeping the system running. I'd better actually understand how all this stuff works. And, you know, if at the point when you go from being secondary to primary, and during your not quite a shift, but when you're the on call, your pager goes off. You're supposed to log in and within like minutes know the system in depth. Say, okay, well, this is the problem. We need to actually take progress toward remedying this.
Yeah.
I was happy to not have that pager anymore, by the way.
Well, just thinking about, I'm still thinking about that 70 million messages a second. So for every 13 seconds that your backlog grows by 1 billion, that's you really want to think quickly there.
The numbers are staggering.
That brings you to another question around the elasticity. So this is now more on the AWS side, less on the Amazon side. I remember a time when the data centers were still growing, coming up, where the capacity planning team had a big role to play. There was one time when I was just trying to figure out how many Spot instances I could get, and I tried to launch 100 X132 XLs. And I got a call from the team saying, "What the hell are you trying to do? Let us know at least a month in advance so we can plan out this experiment that you're running or whatever." How much of a dent does this Prime Day workload make on the AWS side in terms of the capacity planning exercise and so on? Like, is it like, okay, it's big enough that capacity planning has to get involved, or is the AWS size or the scale large enough that it doesn't really matter? There's enough elasticity built in.
I'm not privy to that information, but I think we're now at your latter point where we've got so many customers with so many different use cases, and some of which are on just different utilization cycles. And some of our customers are using Spot instances, and so if we were to need a lot more capacity, then that can presumably come from Spot instances. But what I've heard, and I don't know this directly, is that we are probably not the biggest consumer of compute capacity around.
Got it.
And also, this is a spike versus someone stepping up and from zero saying, I now need this much brand new capacity. We've got all this awesome historical data that's going to help us guide us through these times.
And some very good predictive tools to use that, and some very smart statisticians.
Indeed, and a lot of that we've also made available to our customers. So we do have predictive scaling that uses historical data. I know we just recently launched something new that, in addition to doing the predictive scaling, it publishes some metrics that are kind of like, it's kind of tattling on itself to saying, this is how well or how not well I did at predicting your need for predictive scaling. Like did it too much, too little, and so forth.
That's really cool. Well, we want to transition to the Graviton segment really soon, but just one last follow-up question. What did everyone get for Prime Day?
I went ahead and ordered a whole bunch of PLA spools because they were available for I had I think 4 different colors earlier. I have expanded that to now nearly 10. So yeah, I bought a whole bunch of PLA spools.
I was much more restrained. I only bought one because I think I've got about 20 colors here
I've seen your shelf.
I've got a lot.
It's got a lot of spools.
I got
I'm
one of
actually
those.
in a phase of life where I'm trying to own less things, not more. There's always a lot of stuff I'd like to have, but I'm like, do I really need that or not? And kind of adding complexity only reluctantly.
I can understand that.
I did get a Fire TV for a dashboard and calendar. It's off to the side here. We're gonna do a behind the scenes episode in a couple of weeks, so I'll show that. All right,
That's
well,
awesome.
let's transition over to the Graviton. All right, here we go. This is some very high tech stuff. So I made a very high tech transition. All right, there we go. So, looking at the what's new homepage for Graviton, there's a lot of different announcements here. We've got code build, added ARM support. We've got the new C7G, the Graviton 3s are available in more and more regions. Graviton played a big part in the Aurora databases, mostly backed by Gravitons for Prime Day. So, how's Graviton doing? What's the 10,000-foot view of Graviton?
Our customers seem to really enjoy Graviton because it's awesome it's got great compute performance. It's really good for their scale out workloads. We're innovating really quickly. One thing I love about the whole idea of Graviton is that because we have good insights into our customer workloads, we can use those to very directly figure out, okay, what are the most important features that we need to put into the next generation? And do we need to add more memory bandwidth? Do we need to add more concurrency in terms of more vCPUs? We've got customers doing machine learning inferencing. They're doing encryption, decryption. So, and this doesn't mean that in any way we're looking at the workloads. It means we're looking at very, very low level system utilization. But being able to do that and saying, how can we keep on understanding that, feed that into the design, get that design built and available to customers? Getting that cycle to run very, very quickly to me is the awesome thing that we're able to do with Graviton.
It's pretty incredible that like you said, we're already on the third iteration of them, plus the Inferentium, the Trainium, the different variants there. It's incredible that a physical process that's one of the most complicated manufacturing processes in existence can be iterated upon that quickly.
I really agree. And if I could really kind of plug something we're doing really quickly, tomorrow we're running this online event called the Silicon Innovation Day. And all of these principal engineers that I was just talking about earlier, all of those that are doing the actual detailed hardware and system design, we're going to get to hear directly from all those folks. And in fact, I'm doing a fireside chat tomorrow with Anthony, who's one of the folks behind the Nitro system.
All right, awesome. We're really looking forward to this one. There are just so many questions, we have about the Graviton processor and the nitty-gritty details inside. Like it, for me. By the way, as you're talking about, the Graviton process, I think looking at all of these announcements, one of the things that AWS has been doing really well, at least from the customer side of things, is taking all the managed services and just swapping them out with Graviton processor, or at least offering Graviton as a option for all of those managed services, which makes it really simple for anyone to switch over, because even the migration and stuff is just taken care of. Apart from those, how easy or difficult has it been for customers to switch over to Graviton?
It really depends on the particular workloads. If customers are using basically like interpreted languages or scripting languages, it's generally very, very easy. Sometimes if you're using something like Python, you've got to make sure that your library is available for the ARM architecture. If it's a compiled language, of course, you need to make sure that your whole tool chain is able to compile for that architecture. But by and large, I'm hearing that's pretty easy for customers. Where we've sponsored some different like migration days and migration events, and helping customers to not just understand the benefits, but to actually go ahead and do those migrations pretty quickly. And I have to say I've never heard a complaint. I've seen awesome benchmarks. Our customers, it's actually easier for our customers to share benchmarks than it is for us, because the customers own the most interesting, compelling real world use cases. And the customers can say, under our real world use case, this is what we measured. And the customers can be fully objective. They don't have any particular slants, and they've got no reason to point things one way or the other. Anytime we publish a benchmark, everybody can look at it with, is this legit, or are you slanting this a tiny bit? And the reality is we're very, very careful when we publish numbers to make sure that there's reproducibility all the way back to the bare metal of any of these numbers. When you see the numbers in my Prime Day post, those weren't just like we looked at the dashboard and snapshot it and say, it looks like 37%. We have to capture the data. We have to run the math. We generally have a couple different teams look at it to verify it. It has to go all the way through an approval process to say, are we 100% confident that these are the real numbers? And that means that we don't always want to work that process for each and every number that we have to share. The customers can be smaller, and they don't have to go through as much of it's not a bureaucracy. It's just to make sure that we're being as honest and fair as we possibly can be, and accurate.
Yeah, without a doubt,
customer benchmarks are great to watch.
No, absolutely. We actually recently did a Java benchmark for a bunch of our workloads, and the price performance and just overall performance of those the Graviton 3s, the C7Gs are absolutely mind-boggling compared to what we were getting on the x86s.
It's hard to believe we're now in third generation after just a few years.
Yeah, I think 2018 was when Graviton was launched. Graviton 2, I think, came 2019, if I'm not mistaken. Mm-hmm. So, it's been 3 generations in just, 4 years? Just pretty remarkable.
Now, one of the fun things I'm looking up to learn some more about tomorrow is there's this fascinating idea especially with chip design. Generally, it applies to a lot of technology, but chip design especially, is that each generation of chips gets to actually design its successors. And so the better you can run any kind of simulations, and the better your electronic design automation software works, the faster you can do that, the faster you can iterate. So there's this, it's almost recursion in reverse, where you're recursing back into time and saying, well, these chips were designed by generation N-1, and N-1 was designed by N-2. And at some point we had no chips, so we did things by hand, or we had things built out of transistors, and those transistors were ultimately replacing things built from vacuum tubes. And it's fascinating to think of that dependency of how whatever you do depends on what came before and who came before.
I think I've heard several science fiction films start with this premise of the chips make themselves faster. And I just posted an article into the chat about, funny enough, you mentioned ARM is saying how they're using the Gravitons. They've shifted their EDA loads onto Graviton. So ARM using Gravitons to design better ARMs, and that's just a self-reinforcing positive feedback loop.
It actually is. And this is not just theoretical and not just at the design stage either. A few years ago, one of the coolest places I've gotten to visit in my life was I got to visit a semiconductor fab, and it was actually jointly owned by Intel and Micron, if I remember. And it's so interesting and so complicated. There's all these robots and all these machines, but if you look inside any of the machines, like there's one company that makes a lot of the fab machines that actually take the wafers.
ASML builds ASML.
Yeah, I think
ASML builds most of those, I think.
And if you carefully peer through the vents into these machines, of course, it's just more chips. And so there's this fascinating cycle of how those chips are now building their successors. And now, Stephen, coming back to your science fiction point, the other thing is, anytime you read the story of like, and then we rebuilt civilization, it's actually really hard to do that. It's taken us many thousands of years to get where we are, and to think that we just rebuilt everything from the plans or whatever, not going to happen.
No, it would be really, really hard to bootstrap that from nothing, from raw materials.
Exactly.
One question that I had which we're now starting to see a lot of enterprise customers ask is around energy and energy consumption and the greenness of their workloads, so to speak. So I started looking at this some time ago. The thing that I've always struggled with is that there isn't a good standard or a measure or a metric for it. Historically, we always used TDPs when it came to Intel-based machines to understand what kind of power like TDPs were like a proxy for what kind of power consumption they had. The larger the processor, the greater the processor speeds, the higher the TDPs, and that was your proxy for how much energy got consumed. AMD for a while kind of followed that, and then suddenly AMD decided on a completely different way of measuring TDP. So that kind of went out of the window. And now both Intel and AMD do completely random stuff depending on the chip generation that they're talking about. So that metric is, again, completely useless to predict the energy consumption. How does AWS look at its energy consumption? I know that there have been conversations about, like even James Hamilton, when he talked about the Graviton and the energy consumption of it, he talks about a 60%, better power consumption or lower power consumption. How does AWS measure that? Like, what are the metrics that are looked at when you're declaring something like energy consumption?
Oh, wow. So this could be an entire segment all by itself. It's something that's incredibly important to us and to our customers. We do realize that when we're building these incredibly large scale data centers, that the outside perception is, wow, that's just like burning tons of really precious energy, and it must throw off lots of carbon and huge carbon footprint. We're doing everything possible to switch to totally renewable energy. We're always looking for ways to add efficiency. One thing we launched last year is something called the Customer Carbon Footprint Calculator. I think that's the official name of it. And that attempts to give a very accurate representation to our customers of the carbon footprint of their AWS usage. We continue to add details. And again, this is something you have to get right. We can't just make this fuzzy imaginary number. We try to account for, there we go, customer carbon footprint tool. We try to account for all of the different types of consumption. I think there's 3 different levels, and I think we currently account for the first 2 that are like the direct and the indirect. There's a third one that has a lot more accounting, where you need to take into account different aspects of your supply chain as well. I know that the general thinking is that cloud computing can be and generally is more efficient than running your individual data centers, because we're building new data centers all the time. For most companies, a new data center is, how often do you build one of those? Every 10 years, 20 years? Well, we're building new regions and new AZs all the time. So always learning, trying to make those better and better.
Got it. But specifically around the Gravitons, like the fact that you now have 3 sockets on a board, and you're able to get one Nitro to kind of manage the 3 sockets. So you talk about 192 cores being managed out of that. Yeah, there are tons of efficiencies that automatically come from that kind of architecture, and you're fitting it all in a 1U, if I'm not mistaken. So this entire motherboard kind of slots into 1U. But are there any specific metrics or numbers or the mechanisms by which you measure the?
I'm sure we have those internally.
Efficiency or energy efficiency of those.
Hang on just one sec there. All right. I'm sure we have those internally. I don't have anything to share with you.
Okay, great.
It would be interesting to have some counterfactual of this is what it would have taken to accomplish the same thing on a Xeon or something like that.
Yeah,
but that's very involved to calculate.
Yeah, I can imagine. So yeah, I think we're almost coming up on time. And Jeff, I know you're incredibly busy, but thank you so much for coming over. And we have so many other things to talk about as well. We really hope you can come and join us another time. We love
Absolutely, for sure. Well, you both know where to find me, so more than happy to be able to do that again.
Thank you again. This was really, really fun. And is there any final things we should mention?
One thing I didn't mention is that if you are doing something similar to your own Prime Day, we have an entire team called IEM, Infrastructure Event Management, and they're going to help you with architecture and scaling guidance, and they will virtually sit next to you during your event and watch the metrics and point out anything that's not looking right and make sure that you're going to have a successful event.
Great. And if I'm not mistaken, this is tied to enterprise support, and seems like a very, very invaluable asset to have if you're having any big event.
Agreed.
Awesome.
All right.
Thank you so much, Jeff.
All right.
And thanks for taking the time to talk to us today.
Anytime.
Thank you.
See you later.
All right. We'll see you next time.
Thanks.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money